Hello, and welcome to the section Achieve Code Reusability Using Functions and Generics. In the first video, we're going to talk about how to use function types. So, if you're coming from JavaScript world, you already should be familiar with the concept of functions. In JavaScript, functions are declared as blocks of code designed to perform a particular task or set of tasks, which is executed when something invokes or calls it. We could say that functions are the fundamental building blocks of any JavaScript application. They are how you build up layers of abstractions, mimicking classes, information hiding, and modules. In TypeScript, while there are classes, namespaces, and modules, functions still play the key role in describing how to do things. TypeScript also adds some new capabilities to the standard JavaScript functions to make them easier to work with. First of all, just as in JavaScript, TypeScript functions can be created both as named functions or as anonymous functions. This will allow you to choose the most appropriate approach for your application, whether you are building a list of functions in an API or a one-off function to perform some specific task. Here is the example of how it would look like in JavaScript. This is the example of named function, and here is an example of an anonymous function. Another important thing to keep in mind is that, just as in JavaScript, functions can refer to variables outside of the function body. When they do so, they are said to capture these variables. A good understanding on how this works in a background is an important piece of working with a JavaScript, and so with the TypeScript. We will look at the function scope throughout this section. Now, let's take a look at how can we add a type to our functions. If we would modify our previous example, it would look like this. So, as you can see, adding a type to the function is basically means to give a TypeScript compiler knowledge of what input parameters would expect and what a function will return. We can add types to each of the parameters and then to the function itself to add a return type. TypeScript can figure the return type out by looking at the return statements. So we can also optionally leave it off in many cases. Now that we have seen the typed function, let's write the full type of the function out by looking at each piece of the function type. A function's type has the same two parts, the type of the arguments and the return type. When writing out the whole function type, both parts are required. We write out the parameter types just like a parameter list, giving each parameter a name and a type. This name is just to help with readability. We could instead rewrite our function in the following way. And as you can see, it is working perfectly fine, and it is not throwing any error. As long as the parameter types are aligned and corresponding to each other in terms of types and positions, it is considered a valid type for the function, regardless of the names you give the parameters in the function type. The second part of the function is the return type. We make it clear which is the return type by using a fat arrow between the parameters and the return type. As mentioned before, this is a required part of the function type, so if the function doesn't return a value, you would use void instead of leaving it off. It is also important to mention that only the parameters and the return type are part of the function type. The body is not making part of the function type definition. Captured variables are not reflected in the type as well. In effect, captured variables are part of the hidden state of any function and do not make up its API. The verb to infer means to deduce or to conclude something from evidence and reasoning rather than from explicit state. In the object-oriented programming languages, and so in TypeScript, inferring the type is the ability of the compiler to understand or conclude what is the type of a given statement. And based on the evidence, an explicit statement is not required for that. If you spend some time playing with the example that we just have seen, you may have noticed that the TypeScript compiler can figure out what is the type of function, even if you only have types on one side of the equation. Like in this example, we have a function myAdd, which we do not assign a type. Instead, this type will be inferred based on the function we're associating to it. Also, in the second part of this example, we have a method inside which return type is not specified explicitly, but the compiler will know that this is the number and will enforce you to assign it to a number type of variables. Then, we are returning the addition of two numbers. Adding two numbers will always result in a new number, so compiler can conclude that return type will be number as well.